so today I want to talk about radical substitution reactions. And in AQA, we don't need to know the mechanism of that substitution reaction, but it does help to understand where the electrons go. So if we look at the reaction of chlorine with methane, then that will help us to understand how to produce haloalkanes. So if we start with chlorine, chlorine is a bimolecular compound. It's an element. It's made from two chlorine atoms. So if we look at how they're bonded, this single line here means it's singly bonded. And what does that actually mean? It means that the chlorine atom is sharing its electron pair. Okay, so this is another representation of that single bond. Now, under the action of sunlight, chlorine can break into two atoms. So one chlorine will take its electron with it, the other chlorine will take its electron with it. So we're going to form two chlorine radicals. Now, what does that actually mean? What does that actually represent? Well, it represents a chlorine atom that has 7 electrons in its outside shell, one of which is unpaired, and we're showing the unpaired one there. So if I drew that here for you, so this is chlorine, 1, 2, 3, 4, 5, 6, 7. So there's that unpaired electron that you can see here. So that's what it is that we're looking at. So this is chlorine formed from the action of sunlight. Now chlorine can react with methane, and here this is methane. And again, what do these single bonds represent? They represent a shared electron pair. So let me show that shared electron pair as 2 dots. The chlorine atom will come along with its single electron, and it will pluck the hydrogen away, and the hydrogen will take its electron with it. So what we're going to form is hydrogen chloride. So there you can see the chlorine's electron and the hydrogen's electron, and we're left with a methyl radical. What that is a methyl group with an unpaired electron. So this has gone with the hydrogen, there's one left over. So this is our methyl radical. Now the methyl radical can react in a propagation step. It can react with another chlorine, chlorine like this. So this can pluck the chlorine off with its electron and leave a chlorine radical. So we are forming a chloromethane. So there's the electron that the methyl group had. There's the electron from the chlorine. So there's our chloromethane, and we create a chlorine radical. As again, I'm showing that as an unpaired electron. Okay, so this is known as a propagation step. So we're propagating the radical. Okay, so we're making the radical. Now we can terminate these radical reactions by reacting one radical with another. So we could react the methyl radical with a chlorine radical, and we can form chloromethane. Okay, so that's a termination step. So we're getting no more radicals formed here. And then we can also react the methyl radical with itself. Now this is evidence that we are going via a radical mechanism, because there is no other way to make ethane than by this radical approach. So if we look at this, we can have a methyl radical react with a methyl radical, and that's going to give us an ethane. And I'm just representing that single bond there by the electron pair. So again, this is a termination step, but it's the evidence that we have gone via a radical approach. Okay, so I hope that explains radical substitution. we're taking off a hydrogen and putting a chlorine in its place. Okay.